get to this question, I'm actually going to get you to turn back. Well, it's at the same place, the top of page 429. But I see that there is a direction on here, so I want to just start talking about how we do directions. And this is at the top of page 429, and you can add some stuff to your notes here of different ways of saying directions. So here they have one example, and I've highlighted here, west 30 degrees south. So when directions are written this way, first of all, do you know north, east, south, west? Right? Did you learn something in elementary school to remember that? What did you learn? Never eat soggy wieners. There we go. This spells the word we. I don't know. There's a whole bunch of different ways to remember the north, south, east, west. Now, if you get a heading of west 30 degrees south, you make your crosshairs with north, south, east, and west, and then the W says that's where you're going to start, and then you're going to go 30 degrees to the south, and that would be that direction in the end. Okay? This same angle, and I'll get you to write this underneath, sometimes it's written this way, 30 degrees south of west. So if it's written this way, south of west, you're going south of the west, and now the starting one is listed last. This one says start at west, go 30 degrees south. This one says you're going south of west, you're going south of something, you're going south of west. West is the starting point there. So confusing, right? Because they have two different ways of saying the same thing. And then another direction thing that is used often in navigation is a bearing. You might have heard this saying, oh, get your bearings straight. Because if you can't go in the right direction, you don't know how to work with bearings. Bearings start at 0 degrees, and that's why I put a 0 above the N. They start on the positive y-axis, and they go clockwise. So this arrow here, if I'm 30 degrees away from this, do you make sense? It'd be 90, 180, 270 minus 30. That would be a bearing of 240 degrees. So same thing with the second example. You can highlight west 40 degrees north. Again, it starts at west. Now it goes 40 degrees to the north. We could also write that one as 40 degrees north of west. And if you wanted to figure out the bearing, again, you could count 90, 180, 270, 270 plus 40. This would be a bearing of 310 degrees. So knowing our directions is going to be important because if you get a word problem with some sort of directions and you have to draw it, then we need to know how to read those things. How are you doing? Is everybody almost done? Not quite? I'll pause it. So forest ranger sees smoke rising from a point that lies in a direction of east 30 degrees north. So we start, crosshairs, this is like top view, right? This would be north, this is south, west, and east. And they see smoke rising from a point. East would be the starting point, 40 degrees north. So we draw a terminal arm here. We can label the 40 degrees. And there's some point where, oh, look this, I've even got like a smoke pan. Look at that. Oh. Can you breathe in? You can imagine you smell like burnt toast or maybe you're having a stroke. Okay. There we go. We got smoke rising from the point, east 40 degrees north. and estimates that that distance to this blue point right here, 30 degrees, well maybe I should have like a red point for fire. There we go. That is not 30 degrees, that's 30 kilometers. Okay, but there's just trees in the way to get that point. Roads only run east and west, north and south in this area where the fire ranger is. So the firefighters at the ranger station have to travel east, so they're going to have to go along this way and then north to get there. So we need to find out how far they have to travel. So we need to find this, and I'm going to label that as X, and we also need to find this Y. Can you see that this makes a right-angled triangle? Because we're going east and then north. Because it's a right-angled triangle, you are allowed to use the following tools. These tools can only be used with right-angled triangles. So we're like, I've got this triangle question to solve. I notice it's a right-angled triangle. I can use these things. But what should we use? How do we figure it out? What's useful, what's not? Right? So that's the things you have to decide in a trig question. Like for example, a squared plus b squared equals c squared isn't helpful because I don't know x and I don't know y. So I can't use that right now. Let's decide to see if we can figure out x first. You could try to figure out y first, but let's just see if we can figure out x first. If I have a right-angled triangle and I'm trying to find this x, does it make sense that based on this angle, that's an adjacent side? So in SOHCAHTOA, I'm like, ooh, maybe I can use cos and maybe I can use tangent, because I'm looking for an adjacent side to an angle. What's the other side that I know? I know the hypotenuse. So since I'm looking for the adjacent side and I know the hypotenuse, a review of grade 10 trig, it makes sense that we could set up our trig ratio. And the ka is basically the definition of cos. Cos of an angle, so if I use the 40 degrees, is always equal to the adjacent side over the hypotenuse, and I know everything in that except for x. Now it's simple algebra to get x by itself. Right? If I want to get the x by itself, right now it's being divided by 30, so I can multiply both sides by 30. And this is why people really like grade 10 trigonometry, because it was pretty straightforward to use the definition to set it up, and then it's simple algebra to get the variable by itself. And we go to our calculator. I'm going to make sure my calculator is in degrees. It is. So I can do 30 cos of 40, and just push enter. And I get my x is 22.981. You're going to start noticing, I'm just starting to train you guys already for grade 12 pre-calculus and AP, is that they always want you to go to 3 decimal places. After you've gone to 3 decimal places, you're going to read the question in the end and find out, oh, it tells me to round to the nearest kilometer. So I'm also training you to read a question again at the end, so you don't lose any marks for rounding and stuff. So I'm going to start. We solved x, it's 22.98. Okay? Does it make sense? I can also now solve for y. And now that you have the x, you could do a squared plus b squared equals c squared if you wanted to. You could also think, hey, the y is opposite the 40, and I know the hypotenuse, so I could use sine as well. So now you have 2 options. They both will give you the exact same answer, and you just have to decide which one you like better. For me personally here, I think I would use sine because it wouldn't I wouldn't have to use all those decimal places. Just seems a little bit cleaner. So sine is the opposite side over the hypotenuse. If that's 40 degrees, y is the opposite side. 30 is still the hypotenuse. Multiply both sides by 30, just like before. And I go to my calculator, and now can type in 30 sine of 40. 19.284. And I can take that answer and I can add it to the 22.981 answer. And notice I'm not rounding anything early. And I get a total distance of 42.264, right? Because that's what, how far should the fire, oh, in each direction. Didn't say the total altogether. They should travel to the nearest kilometer, 23 kilometers. Make sure you include the direction. And 19 kilometers. For a total of 42 kilometers. Okay, questions for practice on this one? You can circle 7-11.